Hey everyone, it is now week 2, chapter 2 homework, so I'm going to go over some of the questions. And as a matter of fact, I'm actually just going to go over all of them since there's only 6. And overall, they're pretty quick. I didn't really have any questions from you guys on needing help from the quiz, but know that that is still an option if you need assistance there. Also, make sure if there are issues with Mvantage, you can let me know, but also hit the report a problem button to tell them. So like I found an issue, for instance, with number 1 here. The answer is incorrect on their system. So if you have the same numbers, the same that I do, or just send me what your numbers are and what you got for your answer, and I can tell you if it's right or not, and I will overwrite it to give you the correct score, to give you the points for it. Nonetheless, let's go through how to do it. So we're told here we have 2 isotopes for uranium, 238 and uranium 235. We're given an average molar mass of them, and we want to know the percent of the lighter isotope. And we're told the isotopes are exactly 235 and 238 AMUs. So then that tells us that X is going to equal our fraction of uranium 235, which then means that 1 minus X is our fraction for uranium 235. So when we set this up, we have 235 times X for the fraction plus 238 times its fraction, which is 1 minus X. And those add up to be 236.9. So now we need to go ahead and solve for X, so we can distribute the 238. We have 235X plus 238 minus 238X equals 236.9. Then we can start simplifying. We have negative 3X plus 238 is equal to 236.9. Subtract 238, add 230. Oops, nope, that should be plus 238, sorry. So subtract 238 from both sides. And we get that negative 3X is equal to negative 1.1. Divide both sides by negative 3. And you get that X is equal to 0.3667. And when we make that into a percent, is 36.67%. Chemvantage has an issue with this, and it says the answer is 38.00%. So you could put that in, or if you want to just put that in to get the full credit. But that is incorrect. I've done this question over and over and over, and I don't even understand where they got 38 from. That is number 1. Now, number 2 seems a lot more complicated than it really is. I had a couple people messaging me asking if they wrote out the chemical equation right, but you don't have to do that at all. Okay, this is the law of proportions. So we're told to make nitrogen oxide gas, NO. It needs 14 grams of nitrogen and 16 grams of oxygen. And then we want to know how much oxygen we need for NO2. So then this tells us then that it's still 1-to-1 nitrogen. So it's still 14 grams of nitrogen. But now there's 2 oxygens instead of 1. So that means it's 2 times 16 grams of oxygen. So we need 32.00 if you're looking at 6. And then you're done with number 2. Number 3 is another molar mass, looking for a fraction. We are just focusing on 2 isotopes of cesium. Keep in mind, I may have different numbers than you, especially since it's talking about how the cesium has 39 different isotopes. So they may have given you different isotopes, which have different molar masses. But the setup is still the same. So we have an average atomic mass of 134.0, and we want to know our percent abundance of cesium-133. So we're given our actual masses. So our cesium-133 will be our X, 132.905, which means 1 minus X for the cesium-135 is our X, and 1 minus X. Let me rewrite. X is equal to cesium-130. 1 minus X is 130. So now putting in our actual masses, 132.905 times X plus 134.906 1 minus X is equal to our average of 134. And we're going to solve for X just like before. Now, and we can switch things around. We get negative 2.001x is equal to negative 0.906. Got everything. 1. We get that x is equal to 0.4528. 4 sig figs, that's what our average molar mass is there at that 4. And so then as a percentage, this is 45.28%. Now, this is the correct answer. The answer that they had was like 45.13 or something. I actually submitted an error myself because they did something weird with their math that wasn't quite correct, but my answer is still within their 2% threshold. So keep that in mind. Again, if you're seeing issues, send me what they did, or at least their numbers and stuff, so I can look into it and give you what I get for my answer. Please understand, I have no control over what the problem with numbers it gives you. I don't make the answer key. This is and ChemVantage is completely free, so there's going to be some issues with it because the people that made it don't have all that much time to dedicate to it. Okay, so number 4 is a bit more from chapter 1, which I thought was good to kind of refresh your memory. We're talking about how much water should be displaced by a pure gold object having a mass of 1.450 kilograms. So we're told pure gold, and we're told mass, and we want how much water should be displaced. And so what we should remember from chapter 1 was volume by displacement. So the volume of water displaced is equal to the volume of your object, in this case, our gold. So we need to find volume, and we have mass, and we know what we're looking for. So we can use density as a conversion factor. So you can go to the Google, and you find that the density of gold is equal to 19.30 grams per cubic centimeter. And then we can start with our calculation now. We have 1.450 kilograms. And we can start by converting that over to grams, so that way we have the same units as density. And we have 1,000 grams per 1 kilogram. Kilograms cancel. And then we can use our density as a conversion factor. Remember, you can always solve for it algebraically for volume, but I like to do it this way. We can rewrite this density. There's saying that we have 1 cubic centimeter for every 19.30 grams. We want grams on the bottom. So have it up top. So 19.30, so these cancel, and 1 cubic centimeter on top. Punch that all into your calculator, and you should get 75.13 cubic centimeters. All right. Number 5, I had a few questions on. 5 and 6, I think, are questions that are really easy to overthink. Because you automatically want to go to, chemical reaction. But in reality, they're just conservation of matter. Okay, so we're told that a pure compound A gives off a gas when it's heated, and then it's converted to another pure compound B. we're started with 7.85 grams of A, and we end with 3.32 grams of B. And we want the percent of A that is attributable to the gas that's emitted when it's heated. So conservation of matter, or of mass, same thing, tells us that the mass that we start with is the same as the mass that we end with. So that means that our mass of A, that's all we started with, has to be equal to the mass of B plus the mass of whatever this gas that was emitted, because that's all that we make. So to get the mass of the gas, solving for that, it's the mass of A minus the mass of B. And A, we're told, is 7.85 grams minus B, which is 3.32 grams. We get 4.53 grams of gas. We're not quite done yet, though, because we want the percent of A that is gas, so that becomes gas. So this percent is going to be equal to 4.53 grams divided by our mass of starting A, which is 7.85 grams times 100 to turn it into a percent, and you get 57.7%. And the last problem, 6, the gasoline tank of an automobile contains 75 kilograms of gasoline, which combines with 300 kilograms of oxygen. What is the total combined mass of the carbon dioxide and water produced by the combustion in the engine? This is still conservation of mass, or conservation of matter. Okay, so that means that the mass of our gasoline plus the mass of our oxygen has to be the same as the mass of our carbon dioxide plus the mass of the water. And it just says mass combined. It doesn't want the individual masses of them. So our mass of our gas plus our mass of our oxygen is 75 kilograms plus 300 kilograms. And that is 375 kilograms of carbon dioxide and water produced. That's how much mass we're starting with. That means that's how much we're going to end with. And then we're done. So again, if you have any other questions, please let me know. I hope this helped you guys out, and that you're doing well, you're staying safe and staying healthy. And with that, I will see you soon. Make sure you get your replies on your first posts for this week up by tonight, by midnight, tonight being Friday. And you get your 2 replies by Sunday at midnight. All right, guys, stay safe. I'll see you soon.